Okay, our final video. So we're just going to do OPQRST, our final 6. They look tough, but don't worry. It's sort of a culmination of everything we've done. So 2O is going to be the 7 root 7,800 or 78,125 times a to the negative 7th, b to the negative 49th, c to the 21st. Okay. So remember, when our exponents are a fraction, say we had c to the 21 over 7, then what we do with that is our variable, the numerator becomes the exponent attached to our variable, and the denominator becomes the number outside the root. So that would be like the 7 root of c to the 21st, which is what we have up above. But also I have 21 over 7 here, which we can divide into 3. And sure enough, it does work that easily. It would just be c cubed. So when you've got a root like this, you're actually just going to take the exponent attached to the variable and divide by the number outside the root. So for whatever reason, I want to work backwards. C to the 21st divided by 7, that's just going to become c to the 3rd. B to the negative 49th, so I'm going to divide negative 49 by 7. It's going to be b to the negative 7. A to the negative 7 divided by 7. It's just going to become a to the negative 1. And then here I have an actual number, my coefficient, and I can just 7 root it. And 78,125, the 7 root of that is 5. So I have 5 times a to the negative 1st times b to the negative 7th times c to the 3rd. And then remember, I want only positive exponents, so I'm just going to move them to my denominator. I'm going to get 5c cubed over a times b to the 7th. That's my answer to 2O. We're on to 2p. So 4a squared b cubed all to the negative 2 times 3, and then in parentheses, a to the 6th, b to the 3rd, all to the 1/3. Okay. So this one's got a lot of steps, so we're just going to take them one at a time. First thing I want to do is I just want to use power of a power rule to apply my exponents to my parentheses. So this 4 to the negative 2, it's going to become 1/16. Remember, I flip it to 1/4, and then I apply the exponent to the numerator and denominator. 1 squared is 1, 4 squared is 16. So 4 to the negative 2 is 1/16. Now for these guys, I got to use power of a power rule. So I'm going to do negative 2 times 2, so a to the negative 4th. And then I'm going to use power of a power rule here. 3 times negative 2, you get b to the negative 6th. Okay, now I'm not going to worry about the negative exponents yet. I'm going to come to the other side. So I'm going to start with power of a power rule. I'm going to have a to the 6th to the 1/3. I need to multiply those, and 6 times 1/3 is 2. So I actually have a squared. And then on the other side, I have b to the 3rd to the 1/3. So I do 3 times 1/3, which is actually just 1. So I have a squared b. So 3 times a squared b. Okay. And now we've got 3 multiplied by a squared b. We don't need the parentheses. It's just 3 times a squared b, like this. Okay. So I think at this point, to make it easier, we need to recognize that our negative exponents, oh, actually, no, let's not do that yet. We're just going to jump right in and use our product rule. So I have a to the negative 4th right here, multiplied by a squared. So we're going to add those. Negative 4 plus 2, it's negative 2. So a to the negative 4th times a squared is just going to be a to the negative second. And then I have b to the negative sixth times b. So I'm going to add negative 6. And remember, when there's no exponent, it's like a 1. So I have b to the negative 6 times b to the first. I add negative 6 plus 1. And I'm going to get negative 5. Okay. So at this point, I want to get rid of my negative exponents by putting them on the denominator. And I have this 1/16 over here. Well, I could just drop them down with the 16. And then this 3, it's a numerator. So, or I mean, it's a whole number. So it'd be like 3 over 1. It's on our numerator. And we'll apply it there. So I'm actually going to have 3 on the top and nothing else. And then the bottom, it's 16a squared b to the. Boom. That's the answer to 2p. Okay, so now we have 2q. 2q. Okay, fun looking one. We've only got 4 to go. Okay, so in parentheses, cube root of 8, c to the 9th, d to the 12th, e to the 15th, all squared. Okay, so the first thing is, oh, how do you apply the square to a cube root? Oh gosh, well, we're not going to worry about that. Okay, we're going to cube root everything inside of the cube root first, because it's in the parentheses. So first, I want to cube root 8, the number 8. The cube root of 8 is 2. Now I'm going to take c to the 9th, cube root it. Remember, I divide. 9 divided by 3. So I'll get c to the 3rd. Then I'm going to do, what's that? Then I'm going to do d to the 12th cube rooted. So I divide 12 divided by 3, d to the 4th. And then my e, it's going to be 15 divided by 3, e to the 5th. So now I've taken the root out of it by just simplifying. So we have 2c cubed d to the 4th, e to the 5th, and all of that is squared. And now I just need to apply my power of the power rule so that squared goes to everything in there. I first take my coefficient 2, square it, I get a 4. C to the 3rd squared, I'm going to multiply power of a power rule, c to the 6th, d to the 4th squared, multiply power of a power rule, d to the 8th, and e to the 5th squared, again, power of a power rule, e to the 10th. So I get 4 times c to the 6th, d to the 8th, e to the 10th. 2r. Closing in, 2r. Okay, we've got negative 3 times c to the 1/6, d to the 5th. Oh, I wrote that one, c. And all that is squared times 4 c squared d cubed to the 1/3. Okay. So this first part, I'm going to power of a power rule, apply that to every part of this. Okay, so negative 3 squared is 9. This is a c to the 1/6. So 1/6 times 2 is 2/6. So I'm actually going to have c to the 2/6, not 2/3, but 2/6 we're just going to simplify to, actually I'll just leave this 2/6 so you can see it. And then d to the 5th squared, I multiply 5 and 2, and we get d to the 10th. Okay, now on my other side, it's going to work. So the right side of this is going to work just like on P. Okay. So power of a power rule, 1/3 times 2 is just 2/3. So I have c to the 2/3, and 1/3 times 3 is just 1. So I have c to the 2/3 times d to the 1st. Now remember, since it's all multiplication, I just get rid of the parentheses at this point. Boom. Okay. So how do we solve this? Now I can multiply 9 times 4, my coefficients, and then I just use the product rule. So I have 1/3 here, 2/6, 1/3, c to the 1/3 times c to the 2/3. So product rule, I'm going to add them. 1/3 plus 2/3 is just 1. So I just have c to the first, or just c. And then here I have d to the 10th times d to the first. I just add them, d to the 11th. Boom. There's my answer, 36 CD to the 11th. See, not too bad. 2R, 2S, we've only got 2 to go. Ooh, 2S does not look like a mess. Okay, so I'm actually just going to do the first part, this left part here, and then I'll do the right part, okay? And then combine them, just because I have limited space. So I have 6j to the negative 2, k cubed, all to the negative 2, over 2 times j cubed, k to the negative first, all cubed. Okay. So I'm just going to do the numerator first, power of a power rule. I'm going to apply my negative 2. Okay. So I have first 6 to the negative second, which is 1/36. Okay. Then let's make sure I got that right. Yes, 6 to the negative second. Then I have j to the negative second to the negative second. So I multiply them, power of a power rule. Negative 2 times negative 2 is positive 4. That's a g. J to the positive 4. And here I have 3 times negative 2. I get k to the negative 6. Okay, now down the bottom. 3 times 3 right there gives me j to the 9th. And 3 times negative 1 right there gives me k to the negative 3rd. And a 2. Okay, so now the first thing I want you to see here is that I have this 1/36, okay, which if I have a 1/36 on my numerator, that's just like having a 1 on my numerator and a 36 on my denominator, 1/36. Okay, so I actually just do this 36 times that 2. I have a 36 and a 2 coefficients, they multiply out to 72. And then I had a 1 up here, but I just ignore it, okay, because anything times 1 is the same thing. Now I'm going to use quotient rule. 4 minus 9 is negative 5. So I have j to the negative 5th. And then negative 6 minus negative 3 is negative 3. So I actually have k to the negative 3rd. Okay. And then I've got some negative exponents. So to make them positive, I'm going to move them to the bottom. And then I'd have nothing on my numerator. So when you have nothing on your numerator, you put a 1 there. Okay, so I've got 1 over, let me erase everything, clear this out. So this is the left part of that problem. We've got 1 over 72 times j to the 5th, k to the 3rd. Okay, so now we're going to erase all this. And we're going to do the other part of it. Okay, so we've got 3j over 4k to the 1/3, and all of that to the negative 3. Just like this. Okay, the first thing we're going to do is we see we have a negative exponent applying to an entire fraction. So I'm just going to flip the fraction. 4k to the 1/3 is going to be on the numerator. My denominator will be 3j. And my exponent is positive. Okay, so now I'm going to apply my exponent to both the numerator and the denominator. So first I need to do 4 cubed, which is 64. And then k to the 1/3 cubed, I'm going to use my power of the power rule right there. And I'm going to get 1/3 times 3, which is just 1. So I'm just going to have a k here. And if you think about it, it makes sense. If I take something and I cube it, and then I cube root it, I'm just back where I started. So now, but I still need to apply the 3 as an exponent to my denominator. So 3 cubed is 27, and j to the third is just j to the third. Okay, so now I've simplified both halves of this problem. I've got 1 over 72j to the fifth k to the third times 64k over 27j to the third. So they're multiplying. Remember, when you multiply fractions, you just multiply your numerators across and then multiply your denominators across. So first, I'm going to do 1 times 64k, which is just 64k. Then I've got 72 times 27. Ouch. I'm going to just use a calculator here. 1,944. Okay. Now, then I've got j to the fifth times j to the third. Product rule, that becomes j to the eighth, and then just k to the third. Okay. So now I'm going to look to simplify. Okay. So I've got k's there. I've got a k to the first divided by k to the third. I'm going to do 1 minus 3. I get k to the negative second. Okay. And I'm just going to go ahead right now and just plop it on the bottom to make it positive. So now I've got k squared in my denominator. So now all I need to do is take 1,944, and the 64. So I've got, this is basically, you can think about it like 64 over 1,944. And I just need to simplify that. Okay. So does 8, well, does 64 go into 1,944? No. So it's a number, another number, 8. Let's see, 1,944 divided by 8, that is 243. And 64 divided by 8 is 8. And then I actually can't simplify that anymore. Got 8 over 243. And then I just take my variables. I can just drag them down because I haven't done anything with those. So 8 is my numerator, 243 times j to the 8th. Whoa, what's going on here? What's going on here? Computer. Come on, Jamboard. Well, it's going to be 8 is my numerator, and then my denominator is going to be 243 j to the 8th k squared. Okay, there it is. J to the 8th k squared. You get it. You get the point. Okay. And now I'm on to my final one, 2t. Okay. My numerator is 4 times f to the 1/3 times g to the negative first, all to the negative third, divided by 2, and then in parentheses, 1/4 fg squared cubed. Okay, so the first thing you might ask yourself is, wait, didn't we here when we had a negative exponent and a fraction, we flipped it? So are we just going to flip this here? Well, no. So the difference is, notice how on S, the negative exponent applies to the entire fraction. And here it just applies to the numerator. Okay, so in that case, I'm just going to use my power of a power rule. I'm just going to do everything in the numerator, everything in the denominator, and then simplify. So I'll do 4 to the negative third. I'm just going to apply my negative 3 to everything. So that's going to be 1/64. Then I'm going to do f. So I have f to the 1/3 to the -3rd. So power of a power rule. I'm going to multiply them. 1/3 times -1/3 is -1. And then I have g to the -1st to the -3rd. I'm going to multiply them. -1 times -3 is +3. Okay, so now I've got 1/64 times f to the -1st times g to the 3rd. And of course, I could move my 64 down. I could move my f to the -1st down, but I'm not going to worry about any of that yet. I'm just going to simplify my denominator, see what happens. Okay, so here I've got 1/4 cubed on the bottom. Well, that's 1/64. Okay, and then I have f to the 1st cubed. So 1 times 3 is 3. So the f to the 3rd. And I have g to the 2nd cubed. 2 times 3 is 6. So I have g to the 6th. Boom. And then I've got a 2 here. So the 2, so it all multiplies. It's 2 times all of that. But what's 2 times 1/64? It is 2/64. Okay. So now, first thing you might be wondering is, what in the heck do I do with 1/64 divided by 2/64? What would 1/64 divided by 2/64 be? Well, of course, it's just going to be 1/2. 1/64 is just 1/2 of 2/64, right? We can do our keep change flip. 1/64 times 64 over 2. Okay, and then you're going to get 64 over 128. But again, that's just going to simplify to 1/2. So I'm actually going to take this 1/64 and this 2/64. I'm going to simplify them into 1/2, or this 1. We don't have to. And then this 1 we don't have to worry about is our numerator, because everything we're doing is multiplication. When we multiply by 1, it's the same. So I just have a 2 on my denominator. Then I have f to the -1st over f to the 3rd. Quotient rule, -1 minus 3 is -4. Okay. And then here I have g to the 3rd over g to the 6th. 3 minus 6 is -3. So I have all of that over 2. I want no negative exponents, so I'll move those onto my denominator. And now, when there's nothing left on my numerator, that 1 that we disappeared all in the beginning, it's going to come right back. So we're going to have 1 over 2 times f to the 4th, g to the 3rd, fully simplified. That's 2t. We've done the whole dang thing.